Alright, chaps and chapesers, welcome back to another brain-tickling episode of The Thinkery. Now, picture the teeniest, tiniest thing you can imagine, smaller than that crumb you just dropped down your jumper and didn't notice. We're talking about the electron, this microscopic little blighter that's got the energy of a toddler who's necked a whole jar of jam and refuses to sit still. Today's head-scratcher is this. Why can't the little electron just park its backside somewhere? Why is it always causing a kerfuffle and refusing to settle down? This, my friends, isn't just some dry physics question. It's a rabbit hole that leads us down the bonkers avenues of philosophy, history, and even culture. We'll see how the smallest particle in the cosmos flips our ideas about stability on their head, what its connection is to organized chaos, and could its restlessness be the very nature of the universe? Prepare for your grey matter to do a few loop-the-loops, and let's get on with it. Our first stop on this mind-bending expedition is the realm of quantum physics, specifically a rather peculiar rule known as Heisenberg's uncertainty principle. In plain English, it basically says, you can never know both the exact location and the exact speed of an electron at the same time. It's like trying to grab a greased-up eel with both hands. The more precisely you pinpoint its location, the more its speed slips through your fingers, and vice versa. Why is that, Mr. Heisenberg? Shouldn't science be all precise and logical? Well, see, in this teeny tiny quantum world, the very act of measuring something affects what you're measuring. To see an electron, you've got to bash it with at least one photon of light. That photon's like a speedy little snooker ball whacking into our electron, inevitably changing its position and speed. So, to know where it is, you've got to give it a nudge, and to know its speed, you've got to see the aftermath of that nudge. The result? The electron's always a bit of a ghost, existing in every possible place at once, until you decide to have a gander. And when you do look, suddenly it picks one spot to be in. It's like a magic trick, but with rules even stranger than a ceiling fan running upside down. Right, so where can this quantum physics malarkey lead us next? Down the philosophical garden path, my friend. When the smallest thing in the universe can't sit still, it makes you wonder, is stability even a real thing? Or is everything in the cosmos in a constant state of flux, and we're just too big to notice the perpetual motion? Have a think about it. Planets whizzing around stars, stars orbiting galactic centers, galaxies hurtling through an ever-expanding universe. Even the solid objects we see every day are just a mass of atoms and molecules constantly vibrating and jiggling. So nothing's truly still in the absolute sense. Heisenberg's uncertainty principle for the electron might just be a glaring example of a much bigger picture. Perhaps the whole universe is like a massive, never-ending rave, with everything constantly moving and changing, and our sense of stability is just a jolly good illusion created by our limited perception of reality. Maybe location itself isn't a fixed point, but just a momentary probability of something being somewhere. Let's take a quick jaunt through the annals of science. Back in the day, when good old Isaac Newton was calling the shots, physics was like a Swiss watch, everything ticking along with perfect precision. If you knew the position and speed of anything at any given moment, you could predict its position and speed at any point in the future with absolute confidence. The universe was like a giant machine with every cog and lever in its rightful place. But then along came quantum mechanics in the early 20th century, and it threw a right spanner in the works. This electron and its tiny mates turned out not to play by Newton's rules for the big stuff we see every day. The laws of probability and uncertainty gate-crashed the party, and physics wasn't just about precise predictions anymore, it was about probabilistic ones. Newton might have told the electron, "Now then, young lad, stay put." But the electron, channeling its inner Heisenberg, would have replied, "Sorry, Governor, my life motto is never settle." Quantum mechanics gave the old order a right royal shaking, showing us that the universe at its smallest scale is far weirder and more wonderful than we ever imagined. So what's the symbolic takeaway from this restless electron? We could see it as a tiny emblem of chaos that has a hidden order. The electron zips about in a seemingly random and unpredictable way, but its movements are governed by the laws of quantum probability. So there's a kind of underlying system to the apparent madness. This could lead us to ponder the deeper nature of the universe and life itself. Loads of things we see as random and chaotic actually have hidden rules or patterns governing them. Take traffic in a big city, for example. Looks like a right old mess, but there are traffic laws and a system that keeps it, mostly, flowing. Or the stock market. Seems unpredictable, but economists try to find patterns and rules. This little electron might be reminding us that even at the smallest and strangest levels of existence, there's a kind of balance between chaos and order. And perhaps this apparent instability is the very foundation of dynamism and change in the entire cosmos. Now, let's get down to brass tacks. This fidgety electron is the bedrock of all the technology around us. From the mobile phone glued to your hand right now, to the computer I'm chuntering away on, to the telly you might be watching later. It all works thanks to the movement and control of electrons. If the electron decided to have a permanent sit-down and refuse to budge, we'd have no electricity and no electronics whatsoever. Its very reluctance to stay put is what allows it to hop from one atom to another, generating the electric current that powers all this wizardry. So, you could say its anxiety and instability are its superpower. It's like that brilliant artist whose mind is always racing and can't settle on one idea, but eventually produces a masterpiece. This restless electron is the unsung hero of modern technology. This uncertainty principle of the electron teaches us something rather important about how we think about science. In classical physics, we were always after the precise and definite location of everything. But in the quantum realm, the concept of probability becomes far more crucial. When we talk about where an electron is, we don't say, it's here. We say, there's a high probability it's in this region. The electron's wave function is like a probability map, telling you the areas where you're most likely to find the little blighter. This shift from definite thinking to probabilistic thinking was a massive revolution in science. It showed us that not everything in the universe has to be fixed and certain, and that these probabilities might not just be down to our ignorance, but could be a fundamental part of the nature of reality itself. The final brainwave to consider is this idea of probability present in different cultures. Have civilizations believed that the future isn't always set in stone and that there are always different possibilities lurking? If we have a gander at the history of ideas, we'll find that many cultures have believed in fate and a predetermined destiny. But at the same time, other cultures have focused on free will and the impact of actions on the future. The idea of probability as an inherent part of reality might not be so clear-cut in ancient cultures, but as science and philosophy evolved, so did ideas that embraced uncertainty and multiple possibilities. Perhaps the quantum mechanical view of the world, where everything exists as a multitude of possibilities until observed, gives us a new perspective on the concepts of fate and free will. Maybe the universe isn't marching down a single predetermined path, but is more like a giant tree with countless branches representing every possible outcome, and we're constantly choosing which branch to follow with our observations and decisions. So, in the end, this little electron that refuses to stay put teaches us some rather big lessons. It reminds us of the limits of our knowledge, the ever-changing nature of the universe, and the revolution that quantum mechanics brought to our understanding of reality. It gives us a tiny symbol of order within chaos, and of the probabilities that shape our existence. The electron's eternal dance might just mirror our own jig through life. Always moving, always encountering new possibilities, and always with a bit of uncertainty about what's around the corner. Perhaps the beauty of the entire cosmos lies in this constant motion and perpetual state of flux. Right then, what brain-bending idea tickled your fancy the most in our quantum caper today? Share your thoughts in the comments below. And don't forget to like and subscribe if you feel your grey matter's done a few extra somersaults today, and we'll catch you in the next episode of The Thinkery.